The derivative is the instantaneous rate of change, or the slope, at a single point in a function. Normally when I think of the slope, I think of m is equal to y2 minus y1 over x2 minus x1. But when I'm dealing with the derivative as a function, trying to find a functional value for the derivative of a function, then I'm going to be using this form. F prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x over h. This f prime, that just means the first derivative. If it was f double prime, it would be the second derivative, which would be the rate of change of the rate of change. And then the third derivative would be the rate of change of the rate of change of the rate of change. So that's how that works. There's also another notation that's commonly used. People write dx, dy. That's also the first derivative. And you can write second and third derivatives for that as well. But let's just talk about this. This is the exact same thing as this. It's just written in notation that's more convenient for taking the limit of something quickly. So the y2 minus y1 is here. It's f of x plus h minus f of x. So that's the same thing. It's pretty apparent that's just y2 minus y1. I have a point, and then I have added to it whatever value h is, so that will be the second point. And then this is just h because this is just some distance, it's just some arbitrary distance, and being able to use just h makes it a lot easier for evaluating limits. So for example, just a very simple one, if I want to find the derivative of, I don't know, something really simple, x squared, what I can do is just evaluate this as the limit goes to 0 for h, and then I'll have a function that will give me the derivative for any point of x squared. So f prime of x squared so f of x plus h, that's going to be x plus h squared minus f of x, which is just going to be itself, over h. So this will be x squared plus 2xh plus h squared minus x squared over h as the limit goes to 0. So I'm just going to start dividing the h out. So these will cancel each other out, and then I'm left with the limit h goes to 0, square plus h. This doesn't do anything for this, there's no h in it, this goes to 0. So the derivative of this function is equal to 2x.